Hi everyone, it's Mrs. Keener here. You can hear my voice, but you can't see my face. This is an introduction in the first video for the AP Calculus summer assignment. Are you ready for some calculus, a pre-calculus review? We got this from our friend Stu. Stu makes really great, awesome calculus resources. And this is a long packet. It's going to take all summer to complete, kind of do 2 assignments a week. I really want you guys to read the introduction here. Okie dokie, it's really interesting. And then here begin our assignments. Now, for every assignment, there's a page of notes to go along with it. And the page of notes is posted on, sorry about the blurry, sorry. The page of notes is posted on Google Classroom. I did not print these to save paper. You can print them and highlight them. You can copy them onto lined paper if you learn better that way, but I'm going to make some videos to help explain them, and sometimes I'll just use the paper and sometimes I will do it on lined paper. We'll see. Okay, for this first one, but those notes should explain each assignment, and then if you need additional help, please let me know, and I would be happy to do more math with you. So for this first video, I printed them and then I'm going to highlight and kind of annotate on them. So I'm not going to recreate them live. So lesson A. Okay, you ready? Functions. Here we go. Functions. The lifeblood of pre-calculus is functions. A function, like what is a function? It's a set of points, x and y, such that for every x there is one and only one y value. So one x value cannot go to 2 different y values. There's only one y value. In short, in a function, the x values cannot repeat while the y values can. I'm sorry, I didn't read that very good. In AB calculus, all of your graphs will come from functions. So for the last few years, you've heard the word functions and you're like, what's the big deal? Well, the big deal is you can only do calculus on functions. So if it's not a function, we can't do calculus on it, and it's sad. The notion for functions is either y equals or f of x equals. In the f of x notation, are you hearing me? F of x, we are stating a rule to find y given a value of x. So all of f of x means y. So you'll see a poster in my classroom that says f of x equals y. Let's get into it. If f of x equals x squared minus 5x plus 8, find, and then you see there's 1, 2, 3 examples. So they give you the rule, and here the x has turned into a -6 on the left side of the equation. So on the right side of the equation, you need to plug -6 into here. I'm going to show you like a wrong way to do it. A wrong way to do it would be to say this. Okay? This is equal to -36, but that's not what the rule says. The rule says take your x value in parentheses and square it. So you see here, wherever there is an x, the x has been removed and parentheses have been replaced. And then inside the parentheses goes your x value, because -6 squared is actually a positive 36. So you see here we have positive 36 plus 30, because a negative times a negative is a positive, plus 8, and then we get the answer 74. All right, what happens when you square a fraction? So for b, we're plugging in a fraction into x and x. So when you square a fraction, you square the numerator and you square the denominator. So we have 3 squared is 9, over 2 squared is 14. Sorry about the lights. Here we go. And then how do you multiply a number times a fraction? You do -5 times 13 is -15, but then the 2, you don't do 5 times 2. Okay, we're not multiplying by 5 over 5, we're multiplying by 5 over 1. So the denominator stays 2. And then we have plus 8. How does this become this? By hand. You need to know how to do this. So this would be 9 over 4 minus 30 over 4, because we have to have a common denominator, plus, so 8 is what number over 4? 8 is 32 over 4. So now that we have a common denominator, we see that 9 minus 30 is negative 21 plus 32 equals 11 over 4. All right, this is x plus h. This is a little preview into some calculus here. This is the algebra you need in order to do one of the calculus problems. We'll see. So we're going to do all of this still using this f of x plus h. So still using this function over here. Do you see how that says x squared? Well, instead of x squared, we're doing x plus h squared, like this, x plus h squared, minus 5x minus 5, but instead of x, you don't just add an h, okay? We're actually removing the x and replacing it with x plus h. And then this says minus the entire function. So minus, do you see how it's in parentheses? Why are the parentheses important there? Parentheses are important here because you need to distribute this negative sign. So do you see here we have minus x squared and then plus 5x plus 8. Okay, let's go back to this. X plus h squared. You really need to have this memorized because we don't have time for you to write, oops, can you see that? Write it twice and do your first, outer, inner, last, and then you go, oh, x squared plus 2xh plus h squared. When you see a binomial squared, that should be memorized, and you should just know that that will always come out as x squared plus 2xh plus h squared. And where do I have a little bit room here? X plus h squared does not equal x squared plus h squared. Not equal. Okay, I've been talking a lot nonstop. Distributed the negative 5 to each of these, and then we're combining like terms. And do you see this 5 right here? That is a big old typo. This should be the h. So the h is not being touched until the very last step here. Okay, what happens here? Do you see this x squared and minus x squared? So what happens to those? Hi-ya, karate chop. They go away. Do you see negative 5x and positive 5x? Hi-ya, karate chop. And do you see this positive 8 and negative 8? Yeah? So after we distributed and combined, this is combined like terms, do you notice that what's left over, that every term has an h in it? H and h and h. So since it has a common factor of an h, we can factor the h out. And once you factor that h out, do you see how the h's in the numerator and the h in the denominator divide out? So they also, those are common factors, so they quote unquote cancel, but we try to not use the word cancel. And we're left with this, h plus 2x minus 5. So that's the advanced algebra that you need in order to do a calculus problem. Let's look down here. Functions do not always use the variable x. In calculus, other variables are used liberally. So not just x, but lots of other things. So here we have the area of a circle. Area equals pi r squared. Find the area if, so what does this mean? R has been replaced with 3. So that means the radius equals 3, and we're trying to find what is the area of the circle when the radius is 3. So that would be pi r squared, or 9 times pi. Okay, what's the area if you have 2s? Well, you plug in 2s in for r. So instead of squaring r, you're squaring 2s, and just make sure you square each of them. So we square the 2 and we square the s to get this. Oh, we're going to do it twice now. So we're going to have r plus 1 squared. And do you see how they skipped a step? Look. So what is r? Let's do that middle step. So from here, we're going to have pi times r plus 1 squared. That's going to be r squared plus 1 times r plus 1 times r, so plus 2r, and then plus 1 squared, like that, minus My paper is a little bubbly, so it's kind of popping up. Oh, and you can't even see it. Okay, let me fix that. There. From here, we distribute, and we're going to go in this direction. So we're going to go from here down here. So we have pi r squared plus 2 pi r, I'm distributing the pi, plus pi minus pi r squared. And what cancels? Do you guys see that pi r squared and minus pi r squared cancel? And so we're left with 2 pi r plus pi. Do you see a common factor pi? So in calculus, if there's a common factor, it's factored out usually in your answers. All right, one concept that comes up in AP Calculus is composition of functions. Say that out loud, composition of functions. The format of a composition of functions is, you ready? Plug a value into one function, determine an answer, and plug that answer into a second function. So we have to have two functions. Ready? F is this. Is that same as above or different? Different. And G is this. So A says, so you always go from the inside out. Inside first. So G of -1. Do you see here how we find G of -1? So we plug -1 into G to get -3. And then you take the answer to the inside and plug it into the next function. So we're going to plug -3 into the F function. So -3 squared is 9, minus -3 would be +3, and then +1, and you get your final answer. Now you can go in the opposite order. So B says, now do F of -1 first, and then plug this answer into G, and you see how it's a different answer. Show that F of G of X does not equal G of F of X. So we put the G function, which is 2x minus 1, we're going to plug that into the F function. It's going to go in both places here. So we're actually going to square 2x minus 1, 2x minus 1 squared, because it says x squared, minus x minus 2x minus 1 plus 1. Okay, here's our thing again. We're squaring the binomial. So 2x squared is 4x squared, minus 2x minus 2x. You have to do it twice. And then -1 times -1 is 1. Distribute this to here and here, and we get this line of math. Combine like terms to get this. Then, for the next part, it says take your F function and plug it into G. So we have x squared minus x plus 1. We're going to plug that into the x value here. So then you just distribute the 2 and combine like terms with the -1. Finally, expect to use piecewise functions. A piecewise function gives different rules based on the value of x. Okay, so for part A, you're supposed to find f of 5, and you have to decide, is 5 greater than 0 or is 5 less than 0? Since 5, so you don't start on the left. You know, usually we read left to right. We start on the right side. 5 is greater than 0, so we're going to only plug it into here. 5 squared minus 3. You can't plug it into this one. This one is only for values less than 0. B is fun. B says find f of 2, which is greater than 0. So that's going to be 2 squared minus 3, and then subtract f of -1. -1 is less than 0, so we're going to plug -1 into the bottom function. I have enough parentheses there. So 2 squared is 4. 4 minus 3. This is a -2, but then we're distributing the negative, sorry. So negative and a negative make a positive, and then minus 1. So 4 minus 3 is 1, plus 2 minus 1 equals 2. F of 1, and then plug it into f again. So f of 1 is greater than 0, so we have 1 squared minus 3. Oh yeah, right here. 1 squared minus 3 is -2. But then -2 is less than 0, so you plug that one, -2, into the bottom.